To algebra tiles. Right now you'll be learning how to subtract algebraic expressions. Number one, you're busy working on a problem with algebra tiles. You have 4 green big squares, 2 green rectangles, and 5 green small squares on your desk when your friend leans over and borrows 1 big square, 2 rectangles, and 3 small squares. Write an algebraic equation to represent the situation. This is what your equation should look like. Alright, so notice that these are all green, meaning that they are all going to be positive tiles. So we are just going to draw out the tiles. So you have 4x squares, you have 2 x's, and 5 positive 1s. When you write that, you should have 4x squared plus 2x plus 5. All right, and your friend is leaning over and he's going to borrow 1 big square, so he borrows this one, he borrows 2 rectangles, and then he borrows 3 small squares. So let's see what we have left over. But before we do that, we have to talk about what did your friend actually take away? Well, he took away 1x squared, he took away 2 x's, and he is taking away the positive tiles, right? Positive 1x squared, positive 2x, and he's taking away positive 3 tiles. Therefore, when you subtract these, you should have what's left over. You have 3x squares left over, you have no x's left over, and you have 2 positive 1s left over. Let's just make sure that that is correct. 4x squared take away 1x squared is 3x squared. 2x take away 2x is the same thing as saying 0. 5 take away 3 is in fact 2. All right, moving on to number 2. You see the following problem in your textbook. Use algebra tiles and the zero pair principle to justify the answer. All right, so pretend that this is your expression right here, this 2x squared minus 5x minus 4. That means you have 2 big positive rectangles. You have 5 negative, this is a negative 5x, so that means you have 5 of these. And then you have 4 of these negative tiles. 1 tiles, 1, 2, 3, and 4. All right, so now you are going to use the zero pair principle to justify the answer. So you are taking away 3x squares, but you should notice, how can I take away 3x squares if you only have 2 positive x squares? You want to be taking away 3 unshaded big squares, but you only have 2 of them. Well, this is where you would add in a zero pair. Therefore, you're not actually changing anything when you add this zero pair in, because a positive x squared and a negative x squared are the same thing as saying 0. So you're not actually changing the value of this 2x squared here, but you are making it so that you have 3 positive x squares to take away from the problem. All right, so we're going to cross out 3 positive x squares. 1, 2, and 3. All right, now you have to take away 6 negative x's, and when you look over here on your paper, you actually only have 5 negative x's to begin with. Therefore, when you want to take away 6 negative x's, you should see that that can't be done unless if you bring in a zero pair to not change the value of your x's, but to give you that 6th rectangle to take away. So now you can take away 6 negative x's, 1, 2, 3, 4, 5, and 6. All right, and then lastly we have 4 negative 1 pieces, and you want to take away 1 negative piece, and that is totally doable because you already have a negative 1 piece on the desk, so you can just take that out. Therefore, you should have a negative x squared left over, and you do. You should have just 1 positive x left over, and you do. And then you have 3 negative tiles left over. All right, this would be a good time to pause to see if you understand how to use the zero pair principle. All right, checking your work, you have 2 positive x squares, 1, 2. You have 3 negative x's, 1, 2, and 3. And you have 4 positive tiles, 1 tiles. All right, so you want to take away 3x squared, but you do not have 3 positive x squares to take away. You only have 2, okay? So you only can take away 2 right now. Let's make a zero pair to not change the value of 2x squared, because 2x squared plus 0 is still just going to be 2x squared, but now you have that third tile to take away. All right, so we can just cross this out, and cross this out. Now you have 3 negative x's and you want to take away 2 positive x's. Well, we do not have 2 positive x's to take away, so you actually have to bring in the 0 pair. You need to draw in a 0 pair right here. And let's see here, do you now have 2 positive x's to take away? Nope, you still only have 1. So we need to add in 1 more 0 pair. All right, now do you have 2 positive x's to take away? Yes, you do, 1 and 2. So we can take those away. And then you have 4 positives and you want to take away 1 positive. Do you have 1 to give? Yes, you do. All right, so let's make sure that we have a negative x squared, then we have 1, 2, 3, 4, 5 negative x's and 3 positive ones. Thank you for watching.